Everyone, this is Pravesh Malviya. So in the previous lecture, we discussed about construction of DC machine. We discussed about the various rotating and stationary parts of DC machine. So today we are going to start with our new topic, that is the DC generator, and we'll start with its working. So before we start, let's discuss some basic questions, that what basically a DC generator is. A DC generator is one of a rotating electric machine which converts rotating mechanical energy into DC electric power. And on what principle does the DC generator works? So the DC generator works on the principle of Faraday's law of electromagnetic induction. Yes, so we can relate this law to the electric system of the DC generator here. So we can see that the DC generator is having basically two parts, the rotor and the stator. So the stator has magnetic field system here. So we have these two poles, north and south, and between them we can see that there is some conductor kind of thing. So when a conductor is given some shape, we can say that that's a coil. So there is a coil between those two poles, and when we look at closely, we observe that the terminals of that coil are connected to these curved segments, and these curved segments are actually commutator segments, and that's also the part of rotor. So we can say that there is a conductor whose terminals are connected to these copper segments, the commutator segments, and there is a contact between these commutator segment and these stationary brushes. So these are the carbon graphite brushes, and furthermore they are connected to some load. So this is the load. So we can apply the Faraday's electromagnetic induction law here. Now what we have to do, that we have to rotate this coil along its axis. So when we rotate this coil along its axis, at each end the magnetic field continuously changes. So at any particular end, when the magnetic field continuously changes, it means the conductor is subjected to variable magnetic field. So when a conductor is subjected to variable magnetic field, so it results in an induced EMF across its terminals. So basically when this coil is rotated between these two poles continuously, consequently at the terminal of the coil, which are connected to these commutator segments, an EMF gets induced, and that induced EMF of the coil is extracted with the help of these carbon graphite brushes to the external circuit. So this is the working principle of the DC generator. With the help of this graph, we can understand it easily. So when the coil is at its start position here, so when the coil is at start position, there is no induced EMF, but when it rotates 90 degree from the start position, we see that there is an induced EMF, and this induced EMF can be extracted to external circuit with the help of these brushes. So till now the coil has rotated 90 degree, and again it continues its rotation, and when it completes 180 degree rotation, then these commutator segments exchanges the commutator segments, as there are only two commutator segments. So in the next half cycle, it continues the same process. What happens? The coil again come to its position 180 degree, and then plus 90 degree when it rotates, it induces once again some amount of EMF. So overall, in 360 degree, we can see that we observe a non-sinusoidal waveform here. But when we studied generation of alternating waveform, we saw that in 360 degree the same coil was rotated 360 degree, and there was a sinusoidal waveform in AC circuit when we studied. But the same coil is when rotated 360 degree, here we see that there is a DC waveform. So why? Because it's so. It is because of just this commutator. What happens when AC was generated, there were two slip rings, and here is a commutator. The slip ring had a continuous contact with the brushes, but the commutator actually exchanged their position, because the commutators are actually electrically isolated from each other. So we can see that because of this commutator, we will get DC output. Actually, the coil generates AC across its terminals, but because of this commutator, we get DC output. So we can say that the commutator acts equivalent as a rectifier here. So with the help of a video, we can understand the operation of DC generator better way. So here we can see that there is a coil, and there is a stationary magnetic system. So when this coil rotates in between these two poles, it means the conductor overall is subjected to variable magnetic field. So when it's subjected to variable magnetic field, there will be an induced EMF, and with the help of these commutator segments and brushes, we can extract the same supply which is generated to the external circuit. So when the coil is rotated, the induced EMF is extracted with the help of the brushes and commutator segments. So this is all about the working of DC generator. I hope you enjoyed the video. For any query, you can contact me anytime. Thank you.